Hello friends, I still like proving limits, and today we're going to do a geometrical proof of a pretty nice limit, which is sine of x divided over x as x is approaching 0. So we're looking for a limit x towards 0, sine of x divided over x, and it's supposed to be 1. Why is that the case? Well, let's see. So first of all, we are having a unit circle, and in this unit circle we are computing the area of few figures. Let's start here. Let's say we have this our triangle, and we are having a height. So this is the x value, this is the y value. I hope you're familiar a little bit with trigonometry. So y is equal to the sine of an angle. Oh, I call it x. Well, let's call it maybe differently. Let's call it a, and that's still y, doesn't matter. So y is the sine value, sine of the angle. Let's call the angle x, that's better. Y is the sine of x. All right, so what is happening is, what is the area of this triangle? Well, the area of the triangle is a half base times height. Base is 1, we are in a unit circle, so 1 times height, which is sine of x. Now we're talking about the segment of a circle, so we're talking about this area, and you see it's slightly bigger than the area of the triangle. Well, maybe you're should be familiar with the area of the whole circle, which is pi r squared. And we are now talking about the area of a part of a circle, which is correspondingly given through an angle. And let's say the angle is given in radians. So if we're talking about a part of, and this is corresponding to 2 pi. 2 pi is the circumference of a unit circle. So this is an unknown area, let's say question mark, is corresponding to x. So how can we compute the question mark? Well, you see the question mark divided over, let's say x, would be the same as pi r squared divided over 2 pi. Now I can cancel pi's, and don't forget we are in a unit circle. So r squared is equal to 1. That means the question mark, the area of a segment, is just a half, and that's it, a half times x, sorry. A half times x times 1, which is the radius of a circle. So we're here. And this is slightly bigger than what we have. So we have a half of sine of x is less or equal than a half of x, as you can see. Now let's see what's happening. We're just prolonging this length a little bit, and we're producing such a triangle which is also rectangular. And you see maybe it's similar to a red triangle. Why is that the case? Well, look, this angle x is the same. This is 90-degree angle. This is also 90-degree angle. So the sum of the angles is 180 degrees in the triangle. So those two angles, which are corresponding angles anyway, because of the construction, but they must be equal. So those two triangles are similar, and similarity of triangles means that their sides are combined with the corresponding coefficient, right? So that means we can take, let's say, this length, a divided over y is the same as the whole base of the big triangle 1 divided by, well, let's call it z, okay, divided by z. So can we solve it for z? Yes, we could. We'd produce reciprocals. So that means z is equal to y divided over a, but y is the sine and a is the cosine. So this is the tangent of x. So this big triangle, the biggest one, it has an area of a half 1 times z, where z is a tangent of x, and we're still smaller or equal. See, we can have this chain of inequalities and multiply it first of all by 2, okay, times 2. So what we have is sine of x is less or equal than x is less or equal than tangent of x. Well, but tangent of x is sine divided over cosine. So sine of x less or equal than x less or equal than sine of x divided over cosine of x. And what we're doing now, we are dividing the whole stuff by the sine of x. And you know what? For the sake of argument, we're asking it to be positive. Well, we should rearrange it if it's negative, but it won't change the result because we're still approaching 0, so it doesn't matter from which side. Let's keep it positive. So we have 1 less or equal than x divided over the sine of x, and it's less or equal than 1 divided by the cosine of x. What is happening now if x is running towards 0? Now I don't care from which side, but still we said x is positive, so let's keep it positive. Well, we have still 1 on the left-hand side. We have less or equal than the limit x towards 0 from the right-hand side. We're having x divided over sine of x. And it should be less or equal than the limit x towards 0 from the right-hand side of 1 divided by the cosine of x. But what is the cosine of x at 0? This is 1. So this is 1. What we have is 1 is less or equal than the limit x towards 0 of x divided by the sine of x less or equal than 1. It's only possible, oh, that's nice. If it's only possible if we are really having equality. So that means the limit of x towards 0, x divided by the sine of x, is equal to 1, and that means that the limit x towards 0 of sine divided by x would be also 1 at the same time. This is a very important equality that we proved here. I hope you could follow all the steps. It's a pretty nice geometrical proof, and I hope to see you guys in the next video. All the best. Bye-bye.